Hi, my name is Jay Lecroy. This is my intro video for Robotics Engineering 1 and Robotics Engineering 2. The class is a little bit different, and I'm going to show you how we do the instruction and deliver the curriculum today as I move around with the students. But you can see in the classroom that they are set up in cooperative learning workstations, and they're working in a differentiated way. So, here we go. We're going to talk to each one of the students. All right, Dakota and Tessie are they're REC 1 students, and they're 2 weeks into the course, and they're in Unit 1. And what we're going to look at is their engineering notebook and their worksheets and their robot. So the questions I would ask them is to show me an engineering notebook for the assignments in 1.3. And then show me your rubric for the assignment for 1.3.
No, I'm ahead of you. I'm already on the post test for you.
What's the first step of the engineering process? What's the first step?
Problem identification. Second idea.
And what's the second step?
Brainstorm.
What is brainstorming?
To collect ideas. Possibly add a box to related.
This is very good, by the way. So you get 25 out of 25 out. This is very good too, but this is a year. See how neat she's got it? A real document. You can be able to show people 100 years from now what you're doing. So they need to read it 100 years from now. So as neat as you can. I know my handwriting is as bad as yours is too, so let's work on that. Look at your rubric for assignment 1.6. Flip to it. Keep flipping. Read the first item in the rubric.
All 10 base components are identified.
All right, so I'm counting 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I want you to do is find a 10th VEX component and neatly draw it and show me it so you can get all your points. All right, Trevor and Brent are second-year students. They're working on sensors. They're also the guys that are building the lawnmower, sort of out-of-class project. Right now they've got a robot they have built, showing a robot. And they have got the sensors on the front in which they're working on. What are you trying to program here?
It's going to follow a line with these integrated sensors.
We'll talk loud like when you're normally talking to people, screaming across the room.
Using these sensors, it's going to follow a line, like a black tape line, and whenever it gets to one of these outside sensors, it's going to try to correct itself and go into where the middle sensor is over the line.
What program are you using?
For this program, we want the robot to follow lines. So the first thing it does is gets the sensor data, and using 2 different sensors, it picks up the data from analog port 1 and 3, and then sends it to our code. And this while loop, well, these trees of while loops will say that if this middle sensor equals less than 200, then it will run this program, and if it's the right sensor is less than 200, it'll run this program, and if the left sensor is less than 200, it will run this program, and if none of them, it will do this, and it becomes lost, and then it will turn into a control where I can use the controller to bring it back to the line. If it misses the line and it starts going off into nowhere, it'll allow me to control it back to the line.
One of the things we're doing here is working on experimental work outside the normal classroom. The work that they do in the classroom, we take it and we build on that, and we try to teach them to develop their own projects, their own machines that they could probably use in the real world. Brent's going to show you what we've done so far with this and what this is. So if you'll kneel down and point out what's going on.
Okay. This is, or what used to be, a Hoveround XHD. It's just a wheelchair that we've taken off the seat. We've taken off some brackets that hold on the seat, taken out the factory batteries and put car batteries. What we're going to do is we're going to cut it right in front of the wheel right here. We're going to extend the front end, put the bottom part of a lawnmower right here, and we're going to program it to where it will autonomously cut grass. Pretty much. It'll drive around. You won't have to have a controller. You can switch it on. There's like going to be a little switch on the controller where you can make it to where you can control it. The GPS, the electronics is gonna go in this box right here. You're gonna have a wireless controller. See right now, it's still attached. It drives right now. We're gonna put the wireless stuff in here. Extend the front end, put blades and everything underneath here. And I'm not really sure if we're gonna keep these tires or not. That's it. That's about it.
The classroom is developed this way. They don't have a book. What they have is on their laptop. Each one of them gets a laptop with LearnMate. LearnMate has the curriculum on it. You can see this is REC Unit 1. There are 6 units in the first REC 1, and there's 6 more units in REC 2. 1 deals with building the robot. Unit 2 deals with programming the robot. 3 deals with physics, the movement of the robot and calculating. This is where the student in this class will record core credit in physics. 4 is sensors, 5 is arms, and 6 is a large project for the end of the class. We also use Edmodo to communicate with the students and compile their grades.
Honey trip.
All right, this is Hayes and Austin. They're from Maplesville. They're one of my hardest working procrastinating teams in here. They're second-year students, but they're not up to where the last second-year students are. They're still in the early stages of Section 4 of sensors. So, tell me some types of sensors that you discovered.
An ultrasonic sensor, which determines distance between an object. And then another one would be a bumper switch, which recognizes contact and limits the expansion of mechanisms.
What are you reading off there?
This is my worksheet for 4.1. No, don't get this.
All right, so what type of, you've got a couple types of sensors there. Tell me what's a digital and analog sensor.
A digital sensor is
Well,
has
let's
an
get Austin to do that since he didn't say it.
A digital sensor is like a switch that you can turn on and off, and there's an analog sensor that is it's a range type of sensor.
When you're using these light sensors to define the line that you're going to be programming here, is that analog or digital?
Analog.
All right, Spencer has completed Unit 1. He is a first-year student, been here 2 weeks, and he has now taken the post-Unit 1 test. How many questions? 40 questions. He's got 1 shot at it. How do you think you're doing? Doing pretty good. Need my help? Good, because I'm not going to help you. The post-unit test is for the reading in Unit 1 on the basics and fundamentals of robotics. All right. One of the things that the students have to do is demonstrate or present their prototype, and it must be able to accomplish whatever the assignment is. In this assignment, they must be able to draw a box, program the robot to autonomously draw a box.
Well, I don't think it's